Okay, so let's go through this coordinate geometry question. I need to must explain two ideas. Number one, midpoint theorem. Number two, shoelace formula to find area of a polygon. Okay, let's begin. So this question, you have a quadrilateral ABCD whose points A, B, C, and D has coordinates as shown, except for C. Later I need to find, respectively. The line BD is perpendicular bisector of the line AC at the point M. So here and there they cut each other midpoint. Part 1. Calculate the equation of BD and of AC. So this one requires you to find the equation of those two lines. First one, BD, should be easy to find because you have 2 points. You can find the gradient. You can also have a y-intercept here. 0, -1 is a y-intercept. So you can directly find equation of BD. How about equation of AC? You just need to find out the the gradient of the line AC first, negative reciprocal. Then after that, you sub in one of the points. Or you could just use the point slope formula. Okay, so that's what I did over here. In part 1, equation of BD, just find the gradient, you get a half. Then I just get half x minus 1 because y-intercept is -1. Then for AC, same thing. Just need to find the gradient of this perpendicular line, negative reciprocal of the half. You get -2. Then you have a point A33 which also lies on the line AC. So you just need to sub into the equation, the point slope formula. Then you get, okay, the point slope formula goes like a gradient formula, but you replace the, but you replace the index 2 with a generic y, generic x. Here I'm using a slightly modified version where I multiply the x minus x1 over to the other side, cross multiply, and I get y minus y1 equals to m times x minus x1 over here. Yeah, subbing in, simplify, and you eventually get to 9 minus 2x as the equation of line AC. Now how about part 2? For part 2, they need you to find the coordinates of M. So there are many different ways to find it. Here I'm going to introduce the midpoint theorem. So oh, sorry, that's for part 3. Let's focus on part 2 first. Part 2 doesn't require midpoint theorem. Here, you just need to realize that the point M is the point of intersection of the two lines, BD and AC. So you just need to equate them. We have already found the equation in part 1. Equate them, then solve for x. You'll get you'll get to x equal to 4 and y equals to 1 eventually. Okay? Then for part 3, this one, what does it say? You want to find the coordinates of C. So what is that? It's this point over here. How do you get the coordinates of C given that you know point A and point M? A few different ways. Yeah, so for the first method, A is 3, 3, M is 4, 1. We know that M is the midpoint, so that means these two lines that are highlighted are equal in length. Or in other words, the vertical and horizontal should be the same length respectively. Vertical same as vertical, horizontal same as horizontal. So 2 units here, 1 unit here. How did I get that? You go from 3 to 4, you have to plus 1. You go from 3 to 1, you have to minus 2. So you repeat the same procedure, minus 2 and then plus 1. So as a result, you'll end up with 4 plus 1, 1 minus 2. Then the final coordinates of C will be 5, -1. That is method 1. For method 2, you let the coordinates of the x coordinate of C be A. Then in this case, since the point C it lies along the line AC, we can use the equation of the line AC, y equals 9 minus 2x, substitute x with A, and you get y to be 9 minus 2a. So x coordinate of C will be A, y coordinate of C will be 9 minus 2a, i.e. C is A, 9 minus 2a. So what else do we know? We know that M is the midpoint. From this picture, M is the midpoint of A and C. Now there is a formula for midpoint, which says that you just take the average of the x, divide by 2, because it's average. Take the sum of the x coordinates, you divide by 2. Take the sum of the y coordinates, divide by 2. That's how you get a midpoint. And since we have the points A, okay, I'll just label here, A is 3, 3. C is A, 9 minus 2a. and we know that m here is 4, 1. We just have to take the average of the x with the x, 3 and a, and equate it to 4. Take the average of the y coordinates, 3 with 9 minus 2a. Take the average, add them together, divide by 2. This guy, you equate it to 1. So now you actually have two equations. The left guy compare with left, or right guy compare with right. X coordinate compare with x, or y coordinate compare with y coordinate. Just one of them will do. I pick the x coordinate. Left guy with left guy. Solve for a, blah blah blah. You'll eventually get to a equal to 5. So since a is equal to 5, I can also solve for my, I can substitute into the formula for my point C, a comma 9 minus 2a, which means I'll get 5 comma negative 1. Just have to sub in the a equal to 5. Okay, how about, yeah, okay, that's method 2. Okay, moving on. So that was talking about the midpoint theorem. Now we move on to part 4. Part 4 says, asks us to find the area of the quadrilateral ABCD. So how do you find the area of a quadrilateral? Here's the trick. This is called the shoelace formula. In the shoelace formula, what you do is you identify the 4 coordinates first. Here I labeled it as 3, 3, 0, negative 1, 5, comma, negative 1, which we just found, and 6, comma, 2. So what I choose to do is to go in an anti-clockwise direction from point A to point D. A, then B, then C, then D. And what I do is I will write down in a table format the coordinates. Starting from point A, 3, 3, I write down 3 on top, 3 below. The x is on top, the y is below. Then I go to the next point. After A is B, right? Anti-clockwise. So 0, comma, negative 1. X coordinate is 0, y coordinate is negative 1. So I put down 0 at the top, minus 1 at the bottom. Now I move on to the next coordinate as I go along in an anti-clockwise fashion to 5, comma, negative 1. So 5 on top, minus 1 below. X on top, y below. Then I move on to the next coordinate. As I go in an anti-clockwise fashion, I will reach point D, which is 6, comma, 2. So x coordinate is 6, y coordinate is 2. But here I have to repeat and go back to my starting point again, second time, and I write down the x, comma, y. The x, comma, y. Repeat. The starting and the ending has to be the same. Okay, so now that you have the setup, you have to draw the crisscross. Down, 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 down. Same color, black color. And up, 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 up. Same color, light blue. Then you draw a pair of lines. It's modular symbol and a half in front. So now that we have that, how can we solve this? What we can do is we can take down, the product of all of the downs, minus away up, the product of all the ups. And then you add them together. So what do I mean specifically? Let's focus on the black color ones. 3 times negative 1, you get this guy. 0 times negative 1, you get a second guy. 5 times 2, you get a third guy. 6 times 3, you get the fourth guy. Add them all together on the left, put a pair of brackets. That's the down. Then after that, you put a minus sign, you put another pair of brackets. Then now we gotta calculate the up. What is up? It's the light blue. 3 times 0 plus minus 1 times 5 plus minus 1 times 6 plus 2 times 3. Here. Put a pair of brackets around it. Now you can just type this entire thing in a calculator. Maybe part by part, I'll get 25 minus away negative 5 with our modulus. Okay, so now it becomes 25 plus 5, which is 30. Take the modulus. What do you get? Luckily, it's still positive. So the modulus, you don't need to care about it. It will just remain as positive 30. So half times 30 now becomes 15 units square. Okay, that's how you find the area using the shoelace formula. It's just down minus up. Okay, next part, last part, part V. The coordinates of E if AECD is a rhombus. So what is AECD? You have A here, C here, D here, where is E? So here what you notice is that if you have the original B, it's a kite. But now we're gonna consider a point E such that this shape that we form is actually a rhombus. So what's so special about a rhombus? They are, it's just a slanted square, It's really just a slanted square. If you start off with a square and you make it slanted, okay, all 4 sides still equal. It's just that they are now no longer 90 degrees everywhere. So Let's take a look. So here's how it would look. A, D, C, and then you have a point E being the rhombus. Here you can use the same pattern as what we did in the method 1 of part 3. Method 1 of part 3, we can do the same method. What you need to realize is that in a rhombus, the opposite sides, they are equal in length and parallel, which means that the distance here and the direction is the same. And this means that the horizontal and the vertical will be the same, respectively. So what I can tell is that from point C to point D, I already found out coordinates of C and D, right? I just need to +1 to move to the right and +3 to move up from the bottom left to the top right. So similarly, on my point E towards my point A, I also need to +1 then +3. So working backwards from 3, 3, I can move down by 3 and move left, so -1 to the left. Minus 3 to go down, -1 to go left. When I go down, I reduce my y coordinate. When I go left, I reduce my x coordinate. So that means I'll end up with 3, take away 3, I'm left with a 0. 3 minus 3. 3, take away 1, left with a 2. That's your answer. E is 2, 0.